Hi, I'm Dan, and for my project, I tried to make some fireflies that synchronize themselves. There's a species of firefly called what is it? Photinus carolinus, and they've been known to flash together in large groups, all synchronized. So I wanted to see if I could recreate that behavior using a PIC microcontroller, some LEDs, and some photodiodes. So the main idea here was to create these independent fireflies, or more scientifically, they're actually just little oscillators, right? And they can influence each other by responding to each other's blinks. Each one has an infrared transmitter, receiver, and a gigantic yellow visible LED that makes a pretty show for everybody to see. And that's the basic overview. We'll go into the hardware next. So we're going to go over the hardware a little bit right now. This is a breadboard I have set up. It actually has two Fireflies on it. They're both identical pretty much. So what we have is a photodiode right here, and then we have two infrared LEDs. There's reason there's two is so that this one here can flash at this one here, and this one here can flash back at this one here. Then there's that gigantic LED I warned you about, and central to everything here is the PIC microcontroller buried underneath all those components, and we have a pot here that we use to adjust our threshold for our comparator. So how the hardware works is actually, it's pretty simple hardware. The infrared LEDs are flashed by a low side transistor, which is just driven off of one of the outputs off the PIC, just like we did with our LED display or our 7-segment display, similar fashion. And then the photodiode is a typical reversed biased photodiode. It generates a current through a resistor, gives you a voltage. The voltage goes into the comparator. It's coupled through a cap, so that way only changing voltages get through, and that will null out any effects of ambient light. Like right now, for instance, if you didn't have that and you turn this light on, it would trip the comparator constantly, so it wouldn't be very useful. So that's pretty much it for the hardware aspect. We'll go on to doing some experiments, and I'll show you guys how this works and maybe talk through how some of the code operates. So the theory of operation for these Fireflies is, I think the easiest way to think about it would be if you had a fixed oscillator, say it ran at like a hertz or maybe half a hertz, and it just stayed constant. And then what you did was you introduced another oscillator that also ran at the same frequency, about a half a hertz, and except for this one was special, it could adjust its time based on when the other oscillator was oscillating. So in my case, what it is there's an infrared LED that flashes, and it's picked up by the photodiode, and that causes the adjustment to happen. So the adjustment happens like this. Whenever the adjustable one receives a flash from the fixed one, it determines whether or not the error is positive or negative. So if it was, say, the one that was adjustable flashed before the other one, that would be leading, and that actually gives you a positive error, which means you need to add more time on so that you flash later. If it flashed after the fixed one, that would mean it was lagging, and that it would actually have to subtract some time off of its period to synchronize up. So that's it in a nutshell. It's not quite a PID loop. It takes an average of those flashes it receives, so that way it synchronizes itself to the majority. The idea was that there would be more than two of these. So if you think about it, if you had two of them that were adjusting themselves, if one was leading, one's going to be leading and one's going to be lagging. So the idea is that the one that was leading should try to slow down, and the one that's lagging should be trying to speed up, so that they converge at some point, and if you do the adjustments in very small increments, they actually will synchronize. If you make the adjustments too big, they'll just constantly keep going in and out of phase. It'd be very unstable, like a control loop. So that's basically how the code operates. It does some other nifty things. It has a blanking feature, so whenever the infrared LED is flashed, it actually ignores any interrupts. Actually, it disables the interrupts from the comparator, so that way it doesn't see its own flashing, because it knows it's flashing anyway. So what would be the point? But it also helps prevent it from influencing its own oscillation in that manner. Other than that, that's about all that code is doing that's in this thing. So let's go see how it works. So for right now, we'll do a hardware demonstration with just two of these guys. Right now, there's a piece of paper between them that has a piece of tin foil in it so that the infrared doesn't go through it. And as you can see, I've desynchronized these guys by applying power to one of them before the other, or else you have to wait a while. So now that we have that, you'll also notice I added these red LEDs in there. Those red LEDs are part of the hardware. I forgot to mention there's a debug pin, and right now it's connected to the comparator interrupt. So whenever it gets a flash from another Firefly, that red LED should come on. It's pretty handy for debugging things. So I'm just going to move this paper out of the way so they can start to see each other, and we'll watch what happens. Doesn't take very long. If you look, you can see those really bright white flashes in the lower part of the screen there. That is the output from the infrared LEDs. The camera can see it, but if you're looking at it with your eye, you can't see that at all. So when the red LEDs stop flashing, that means they're synced within probably about 3 milliseconds of each other. The best I've seen was under 30. Your eye can't really detect it, so to your eye it looks great. So I just stuck with that because it would take a lot more time to get it better. So I was actually pretty excited that it synchronized at all. So I'm pretty happy with the way it's functioning right now. So without further ado, we should see what happens when we connect 4 of these together. And we'll move down to the floor for that because there's a lot more room, and we'll give 4 a try. So move down to the floor here. I got 2 over here that are flashing unsynchronized, and I have 2 over here that are also flashing unsynchronized. So I got them about 2 feet apart. They'll actually work about 4 or 6 feet apart, but the problem is that it makes it really difficult to take a video of it when they're flashing like that. So I'm going to try it like this and see what happens. You can see the red lights are basically responding to every time you see one flash. It's responding to it. And then slowly but surely, they all synchronize. seen a brief experiment to show you what these guys are capable of doing. Let's talk about some of the problems I had while I was constructing this project. One of them was I couldn't get them to synchronize at all. I had to talk to a friend of mine that is actually a controls engineer, and he basically said, just try adjusting them in small increments. So I tried that, and what do you know, he was right, it works. One of the other things I don't like about this is that I don't have an amplifier on the photodiode. I'm just using a really quick and dirty resistor. There's not a transimpedance amplifier the way you typically would use it. So the range is kind of limited, and it can be a little finicky. I had to play with some values to get it to work as it is right now. So that was a challenge also, and I don't have an oscilloscope to see what's going on. So that just added another problem. As far as the code goes, I spent quite a bit of time trying to get the comparator to work. I was able to get the comparator to work with an external voltage reference, but I tried to configure it to run from the internal voltage reference, and I could not get it to work no matter what I did. I even took the same code that I had working with this one with the external voltage reference, where I knew it worked, and I tried the internal reference and I could not get it to work. I don't know if there's a problem with the documentation or if I was just doing something completely wrong, but that's an improvement I'd like to make, would be to have that inside it. And other than that, I did have a weird problem where the pins, the outputs that I'm using to control the LEDs were actually toggling when I didn't expect them to be. And I couldn't figure out exactly why this was happening, but I made some test code, and from what I could tell, the macros that MPLabX gives you, or Microchip gives you, where it's like RA1 equals 1 or RA1 equals 0, well, if you use like two of them in a row, like RA1 equals 0 and RA0 equals 1, it almost looks like it writes to the whole port, so you might see your pins toggle when you're not expecting it. So I ended up making my own macros that just write to the entire port all at the same time. Everything's ORed in, so it doesn't write to any bit it doesn't need to. Other than that, I'd say those were like the biggest challenges I had. I'd like to, like I said, add an amplifier to this. There's some code changes I've already been thinking about doing where I don't like the way it averages the flashes out, because it only does it when it receives them. I'd like to make something that does it based on time, so that way the error slowly goes away, if there is none. And I'd also like to, if there is no flashes, I mean. So there's no point in it waiting for a flash to happen. And another thing that can happen too is if there was some sporadic flashing for some reason, it could keep taking over the interrupt forever, and I don't want that to happen either. So I might have to put some code in there to deal with that. But other than that, I think it was pretty successful, and I learned quite a bit about some control theory, a little bit, and I learned about some things, writing the code that I'd never thought I would have to deal with. So it was a very good experience. I really enjoyed it, and I hope that you did too.